Good morning, my name is Adam. Welcome to the next episode of Tapir tutorial series. In this episode we will see how to integrate Tapir with cats effect and how to expose an endpoint where the server logic is defined using cats effect's IO monad to the outside world. So let's start. So we will actually use the same endpoint description as we have used in the first tutorial. So I will assume that you are familiar with the material that we have presented over there. It covers the basics of how you describe endpoints in Tapir and how you expose endpoints to the outside world. So the endpoint description is going to remain the same, and that's in fact going to be a common trait of any endpoints that you want to expose using the previous approach where we have used the so-called direct style and the netty sync server, which allowed us to express logic in a synchronous blocking way. And when we compare this to an endpoints that we want to expose using cats effect and the IO monad to define the logic, so the endpoint description in both cases will be always the same. So that's not only for the hello world endpoint, but that's like a general trait of how Tapir works. So the endpoint descriptions are kind of independent of what kind of effect you use to describe the server logic. So we have the endpoint description, and what we would like to do now is to couple it with the server logic. Since we are going to use cats effect, we are going to use purely functional programming, right? Cats effect is one of the most popular functional effect systems out there. I think it might be one of the most popular functional effect systems when it comes to pure functional programming being used commercially in general, not only in Scala. So when we use cats effect, when we use the purely functional approach, any side effects have to be captured as values, of type IO, well, some kind of an IO type. So the same here, right? If our server logic will want to run some side effects, typically like when you invoke an endpoint, you will probably like query a database or send a message to Kafka, or maybe invoke another endpoint. In our example, we will just use plain old print line to demonstrate, but all of these are side effects, right? And when using purely functional programming, you want to constrain how these side effects are invoked. You want to be able to manipulate them as values, so we want to represent them as instances of the IO monad, and the same over here, right? So we need to somehow couple this endpoint description that we have here with server logic, which will be expressed in terms of the IO monad, right? So just to remind you, the inputs that we have defined for our endpoint are of type string. So the server logic will have to be parameterized with the data that is extracted from the request. Here it's a string, and then we need to return either a unit, because we don't really have any error outputs here, or a string again. So this string corresponds to this string body over here. So that's the successful output, right? So that's the shape of the function that we used to provide before in the direct style. However, notice that this function might have arbitrary side effects, right? So in purely functional programming, we want to actually constrain this, and we want the side effectfulness to be visible in the types. That's why the result over here should be wrapped in an IO monad, right? So that's the shape of the function that we need to provide, with which we want to couple our hello world endpoint, right? Okay, so we can actually do that using the .serverLogic method. So the serverLogic method actually takes a single type parameter, which is the effect type that we are using to express our server logic. In many cases, this type parameter can be inferred from the shape of the function that you provide, but I think it's usually worth to actually provide it explicitly because it gives you better error handling and also communicates the intent better. So I will just write the type parameter explicitly here, saying that it's cats effect IO, so we need to import that, but we also need to add the Tapir cats dependency, which will bring in the cats effect transitively. So we want to provide the server logic with the result wrapped in the IO effect, right? And you can see that IntelliJ properly infers and gives us the proper type hint. So we will get the name, that's from the request, right? And then what we want to do is we take the IO constructor, we print line, so this will end up in the server logs, and we're saying hello to name. And then what we will do is we'll sequence it with another effect. It will be just returning a pure value, so we return a pure effect description, and here we need to provide the value that will be mapped to the response, right? It's a successful response, so we just say it's a write hello name. Okay, and so once again, to explain the types over here, so what we need to do is we want to, in response to the values that are extracted from the request, we want to provide the values, we want to provide the description of the computation. So the description of the computation is expressed by the fact that we return an instance of the IO monad. So we want to provide a description of the computation that will be run when this endpoint is invoked. And this description says that first print the following string to the server log. First bring the following string to the server log, and then run another effect, which here just returns a pure value, but this might be, querying the database or something like that. And this pure value says that we want to return a write, meaning that this value should be mapped to the successful response of our endpoint. Okay. So, and that's in fact all there. We have already coupled, we have an endpoint description over here coupled with the server logic. So what we need to do now, no idea why this is red, by the way, what we need to do now is we need to expose that endpoint to the outside world, right? So before we have used the netAsync server to expose endpoints where the server logic has been defined in a synchronous way. So here we can't really use the netAsync server. It will actually be a compile time error if we try to expose an endpoint coupled with logic using the IO effect type. So yeah, if we try to expose this endpoint using the netAsync server, we will get a compile time error because the effect types don't match, right? The netAsync server uses the identity so-called effect, and here we use IO. So we would get a compile time error, but still we need something else. And there's a couple of options that Tapir provides, a couple of integrations. We are going to use the http4s server, because that's the most popular server, I think, when it comes to the cats effect ecosystem. So we are going to use the http4s server dependency, and what we need to do is we need to somehow convert this endpoint, this Tapir endpoint, into something that http4s understands. And this is done through a server interpreter. So we have seen already two interpreters. We have seen the netAsynchronous interpreter. We have seen the OpenAPI Swagger interpreter. So the OpenAPI interpreter takes endpoints and returns the endpoints that can be used to expose the Swagger documentation. Here we will take the endpoint and we will transform it into a type that is understandable by http4s. So what we will do is we will create hello world routes object. It will be of type http routes IO. So we might need to import that in a second. And what we will do here is we will take the http4s server interpreter, and we will parameterize it with IO. Yeah, we need to import that. And we will call two routes. Hello world endpoint. Okay, and we are almost done. So what we did here is we are creating the http4s server interpreter, which allows us to convert any server endpoints, so endpoint description plus server logic, into an HTTP routes instance. So such instances can be consumed by http4s to actually expose things to the outside world. Okay, so there's one final step that we need to do, and that is actually exposing and starting the http4s server, right? So if you have ever used http4s before, this will look very familiar because it's just looks as exposing any http4s routes defined in any other way. But let's go through it. So the first thing that we actually need to do is we need to change the way we define our application entry point, right? So here we're using @main method. So in case of code that uses cats effect, we need to do slightly differently because it's not only our server logic that's defined using IO computation descriptions. The entire program, the entire application will be one big IO computation description. So this one big IO will contain starting the server, binding to the port, exposing the endpoints, handling the requests, right? So we need something that actually understands we need something that understands the IO computation descriptions, and this something should also actually run our code, right? And this is handled by the IO app. So we will turn this into an object hello world Tapir extends IO app. Okay. So this IO app comes from cats effect, as you can see over here. So when we extend the IO app, what we need to provide is we need to provide the run method. So as you can see, the run method should return a computation description, in the end yielding an exit code, right? So when our application finishes. Our application will never finish because it will just handle requests in a loop, but like other applications might actually provide an exit code, sorry. Okay, so what we have to do now is we need to actually start an http4s server, and to do that we need to use a specific http4s server implementation. So http4s itself is kind of it is an API which with which different server implementations can be used. So it sits kind of between in the middle. So there's Tapir, there's the Tapir API of describing endpoints, there's the http4s API of defining routes, and then you have a couple of servers which you can use. So there's Blaze and there's Ember. We are going to use Blaze over here. I guess for such an example it doesn't really matter. We need to add the dependency, so we need to use org http4s Blaze server version, yes, this one. Okay, so now we need to configure our Blaze server builder. We're going to use the IO monad to represent side effects. We're going to bind to port 8080 and to localhost, and we are going to expose the HTTP application where we will attach the root context to our hello world routes. Otherwise we want to report a not found if well, this will actually match everything, right? But if these routes don't match, well, okay, it won't match everything. So if these routes won't match our request, we want to report a 404. We need to import the router. That's from http4s. Then we represent this as a resource. We want to use the resource with an IO never. So by calling .use, we actually create a description which actually starts the server, because that's just a description of a resource, so of a pair of functions, one to start the server, one to stop the server. So we are starting the server, but we just never stop using it, right? So we use it indefinitely, well, until the application is actually killed, and then we can do, if this ever happens, we can then exit code success. Okay, just to make the types happy over here. Okay, I think we have this ready, so we can actually try running it. So yeah, we have our description, we have our interpreted routes, we have our server. So let's try running it. Worst case, we will see some errors. We don't see any errors, so we can now test it. So okay, we've got a hello Jane over here. We've got saying hello to Jane in our server logs. We can say Peter, hello Peter, saying hello to Peter. Okay, awesome. It seems to work quite nicely. Okay, so before we conclude, I think there's one more thing that might be very beneficial here, is seeing how we can actually integrate other features that we have learned about before, such as exposing documentation for our endpoints. And it's, once again, is going to be very similar to what we have seen before. So to actually expose documentation, we need to add another dependency, and that's the Swagger UI bundle. Okay, so let's divide this into sections. So that's our logic, that's our application logic section. So this will be our documentation section. So what we first need to do is we need to obtain the Swagger endpoints. So we need to create description of endpoints which will expose all the Swagger stuff. So all the Swagger JavaScript, the CSS, the HTML, plus our YAML, plus the OpenAPI YAML describing our endpoints. So we invoke the Swagger interpreter, which comes from the dependency that we have just added, and we call the from server endpoints function. Once again, it's beneficial to explicitly state the effect type over here, so that there are no weird type errors. And we provide the list of endpoints which we want to document. So that's our hello world endpoint, and we need to provide the title, right? So my app version 1.0. Okay, so now what we have here is we have a list of server endpoints where the server logic is implemented in terms of the IO monad. So that's exactly what we need to be able to expose them using the http4s server, right? If you recall, maybe in the previous examples we are using the net asynchronous server, and over here we had to provide the identity type constructor to say that we want the server logic to be implemented using the identity so-called effect. Here we need our effect type to match in all and the endpoints that we want to expose, right? So the same effect has to be used over here, and it has to be understandable by the server as well. So the second thing that we need to do is we need to convert these Swagger endpoints into routes. So what we do is we call the http4s server interpreter once again, and we convert to routes the Swagger endpoints. Okay. The last thing that we need to do is we need to combine these two routes into a single value. IO, and this can be done using hello world routes, and then we use the monadic plus operator to combine them with this Swagger routes. Okay, so this plus over here, it comes, we need an import for that. The import cuts syntax all star. Okay, so this should compile now nicely. Okay, so we've got all routes over here, which combines the hello world routes and the Swagger routes. So the last thing that we need to do is we need to pass them over here. Okay, so let's try running our example. No main class found. It wasn't saved properly or what? Okay, yeah, that's some weird IntelliJ quirk. Okay, we have started the server, so now let's see how if our documentation works properly. So we are switching to the Swagger UI. You can see that there's this hello world endpoint. What we can do, we can try it out, and we can say Adam over here. We can execute it, and there's a hello Adam in the logs, well, in the response, and there's also a saying hello to Adam in the server logs. Okay, awesome. So I think this concludes this tutorial. So just to do a short recap on what we did. First of all, we have the endpoint is described in exactly the same way as we have done before when we have provided server logic in a synchronous way. So the endpoint description remains exactly the same. Then we need to couple it with the server logic. We need to use the server logic method on the endpoint. We can provide the effect type explicitly. We don't have to. Here we do, just for clarity. Then we provide the implementation of the server logic, which contains of logging something to the server log and providing the response, the data from which the response is created. Such an endpoint description coupled with server logic requires a server interpreter which knows how to deal with I/O, with logic expressed as an I/O computation description. Such a server, there's a couple of these interpreters which know how to deal with them. The most popular one, I think, is in the Cats Effect ecosystem, is the http4s server. So what we do is we use the interpreter to convert our endpoint into an http4s type called http routes, and then we need to actually start the http4s server, so which we do below over here. So again, that's like fairly standard code used to start an http4s server. We need to provide the routes that we have created with our interpreter over here, and then we can start our application. When it comes to documentation, it's almost exactly the same as with other interpreters. The main difference, of course, is that we actually have to use we have to provide the proper effect type over here. So instead of identity, as we use with the synchronous one, we provide I/O. Yeah, that's it. And any other Tapir feature that we have covered so far, or that we might cover in the future, such as JSON integration, error outputs, error variants, and so on and so on, they can all be used exactly the same with Cats Effect as we have used them in the synchronous version. Okay, so that's all. Thank you very much.